Hello, folks. Hello, hello. So I was thinking that I've been streaming for 2 days straight. Uh, that I should take a break today, but you know, I think if I took a break now, that would really show some flaws in my character. I think this journey that we've embarked upon is really good for character building, and we should see it through till the very end. So yeah, with that in mind, let's get to the next day's problems. Day three. Okay. Ah, it's a reference to Advent of Code 2020. Very nice. Note of their voltage ratings, your puzzle input. Okay. Arrange into banks now. You need to turn on exactly two batteries. The voltage that the bank produces is equal to the number formed by the digits on the batteries you've turned on. 2 and 4. Okay. Is this sorting? No. Ah, I see. Exactly two batteries. Okay, okay, okay. So you just need to select two batteries that produces the largest number. I see. Um, okay. Interesting problem. Cool. Look at the puzzle input quickly. It's what is this number? How many digits is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 20, 30, 40, 50, 60, 70, 80, 90. Okay, probably 100 digits, right? 100 squares is still not a very large number. So I think we can just do brute force because 10 choose 2 is a very reasonable number. Okay. I think, yeah, with that in mind, let's just let us just start this. Um, is the chat disabled for the stream? Let me try to enable chat. Are there any stream settings here? Hang on a second. It's my old stream. Let's go to channel. Live. We are live. Edit the stream. Or you at chat? No, it's not made for kids. Okay. Save. Does that enable chat? I have no idea how the streaming thing works. View your channel. Live. Does that enable chat? Okay, chat is enabled now. Very nice. Cool. Uh, Let us get back to the stream and continue with the puzzle. Let's open a new branch. Uh, Check out main first. Branch create. Starting at main, day 3. Very nice. Let's see. Okay. What do we have to do now? We have to, let's open up input file reader C, or let's pull up the contracts here. Okay. So now what we need to do is input file D, file. Let's create an input file. D star file is equals to, okay. What is this called? Input file reader. Okay. So we have a file that's been opened now. What do we need to do? We need to basically have a bunch of lines or a bunch of digits that corresponds to each line. Um, how do we want to store this? Well, actually, it's already stored in the input file T struct. So we can just go over that and have a sum that is equal to 0 initially, reference size ti equals 0, sum less than input file, or file rather, file dot non-lines I plus plus. If dot line length of I is equal to 0, then we skip. Otherwise, we have to, for size ti equals 0, I is less than file dot line length, or rather this, let's make this j. Line length j plus plus for size t k equals 0, or k equals j plus 1, I think. K is less than file dot line length k plus plus. Um, let's say that our current best is, so the numbers go from 1 through 9, right? Yeah. So there is no zeros, which means we can say our best is 0, because 0 is the minimum possible number that we can have. And now what we want to do is we want to say that let's include math.h and say that best equals max, best comma, or there is no max defined. That's tough. Size t max, size t a, size t b. Can we make this inline and say that a is greater than b? If that is the case, return a else b. Let's say that now best equals max best, comma, size t of j times 10 or sorry, not j. Um, file dot lines of j minus 0 times 10 plus size t file dot lines of k minus 0. And that should be good, right? Why are we complaining here? I think, oh, we do need the final. Yeah, that should be okay now. Um, so we have the best, and this best we are going to just add to sum, and we're going to print that out. Printf, actually not before we free input file, but we have to now output this best, or sum rather. Very clean solution. We have some issues. Oh, because we didn't modify the compile commands. JSON file, reader.c. What else do we have? List.c. What's up? Max is not defined. Why? Inline doesn't work. That's crazy. Okay. Let's open up our terminal. We need to copy the input first. Hang on a minute. Let's say that pv paste goes into input.text. Run main. Does that match up? Let's see. Oh, that doesn't match up. This seems odd. Why wouldn't it match up? Oh, we have undefined behavior now. Very cool. Undefined behavior. This looks okay. Should we print the line? Oh, I know what we're doing wrong here. I know what we're doing wrong. Since the last element will always be the null character, so we must always account for that. I'm still doing it wrong. Interesting. Okay, let's get back to doing this. Is this not wrong? Was that what was wrong? Please match up for you. So how undefined behavior? Right. Okay. 300, that's reasonable. Seems like now this is done. 98, 81, 47, 92, 98, 89. Okay, maybe we are wrong here. Maybe line length is the string length. Yeah, that might be true actually, yeah. 357, yeah, I think that's right. Wasn't input. Seventeen five 17,524. R2. Escalator doesn't move. It's the big red voltage limit safety override button. You lose count of the number of times she wants to confirm. Yes, I'm sure. I'm decorating the lobby a bit while you wait. Exactly 12 batteries. Oh, God. Shit. That's crazy. 12 is a bigger problem. It's a bigger problem. Yeah. 12 is quite big. Uh, but yeah, it's still not impossible, I think. We can just do it with like a simple look ahead algorithm. So, like, let's say we fix the first guy to be 9. For the second digit, we must choose just the largest digit among the next the suffix, but we cannot include any digits past the 11th digit. Okay, so let's write a proof. Let's write a proof. Day 3 advent of code solution proof. This is part B. So let's write a mathematical problem. Given a string as in beautiful work mode. This is why I love Emacs. Okay. Given a string S that takes on digits 1 through 9 and an integer k that is less than the size of S, find the largest SI1, SI2, find the lexically largest SI2 all the way up to SIK, where IF J, where J is less than K, right arrow, IJ is less than IQ. Basically, the problem that we are trying to solve for here is that we want to find a substring of S such that that substring is maximal, right? It's maximum. among all the substrings of length k. And a substring is defined such that every character is picked such that the order in the original string is preserved for that, right? Okay, and how do we solve this problem? The solution that I'm proposing is quite simple. Um, so here's the lemma that we will be using. Um, given that S prime is optimal, or let's just call it that, S opt equals, SI1, SI2, all the way through SIK. We have that for all one is equal to, for all j in bracket k. So bracket k is the set containing 1 through k. We have that actually write this here. What the heck? Control CXO. We have that for all S of ij is the max in the set Sij is equals to the max in the set k in, let's say k in what, I j minus 1 through I, sorry, j plus 1, I think. Or no. J minus 1 to I um, k minus j plus 1, I think. Hang on. So j is ij is the jth guy, right? How many more elements should be present in the set? So let's say that k is 5 and j is 2. In that case, there's 3 more guys that come after. 5 minus 2 is, it's just k minus j. Thanks. There's 2 more elements that come after. Sorry, there's 3 more elements that come after. I think this is wrong, actually. Yeah, I think this should be just k minus j. If no, shouldn't be k minus j. Should be what? So, okay, let's say that 1, 2, 3, 4, 5. Let's say j is 2. There's 3 more elements that come after. Let's say that the size of S is 10, right? And we're choosing the 5 substring of 10. Um, so it should actually be n minus k minus j, right? N minus k plus j. 5 plus 2 is 7. Yeah. If j is 2, 5, then after we select ij, we need to select 3 more elements, right? So j can be at most 7. In this case, 8, 9, 10 needs to be selected. J can be at most 7, right? What if everything is not in terms of, we're assuming everything is one indexed, which is kind of weird here, but oh well. Yeah, I think we should be okay still with this approach. N minus k plus j, yeah. This makes sense now. And this will be S of k. Yeah. So this is the lemma, right? And we need to prove this. What is the proof of this? The proof of this lemma is that we'll take a proof by contradiction. Suppose that there was, for some j in bracket k, there was some ij such that how do we enter this in? This was not equal to that, right? Yeah, okay. Then note that S of I1, S of I2, all the way up to S of Ij, or j minus 1 rather, S of I, let's say that O equals, or sopt equals, or let's just say opt. I'm trying to do too much. C opt, yeah, that's fine. Something I can live with. C opt equals this value. Then note that this and with anything is less than si1, si2, all the way through to sij minus 1, or yeah, sij minus 1, and then c opt followed by anything else, right? Why aren't we able to create logic previews here? Is there a bug with this? Maybe we just have to use cdots. Okay. What? Okay, nice. Nice. Okay, this is true. Given that they are both strings of the same length. Okay. Note that even after we select C opt, we have n minus k plus j characters left in S to play with. Hence, we are able to construct the right string. Okay, that is the complete proof. And I think we can use this lemma to basically create an algorithm that lets us select the largest 12 length string. So yeah, I don't even want to call this a lemma. This is the solution. Let's get back to programming. Unsigned long, or sorry, ULL is unsigned long. Okay. Size 2 digits is, which is some 12 digit plus. Okay. So what do we do now? We now want to say that for size t, I equals 0, I is less than. So what is n? N is the line length, right? Line length of I. K is 12. So I is less than n minus k. What was the proof? Proof dot org. N minus k plus j. But we have to minus 1, right? N minus k plus j. But j itself is also smaller. So I is equals to 0. I is less than n minus k, which is 12, plus j, which is I plus. What? This doesn't make sense. Oh, j here is a digit, I guess. Yeah. A digit. Yeah. Last digit is 0. Last digit is equals to, let's change this to ULLs. Oh, so we can't use I. Um, I think this works. Yeah. And over here, we should set last equals best times 10 plus first digit. Let's try it on it. That's not showing. This is the answer. This is not the answer. What happened? 9999. Oh, we are not. We are starting from 0 every time, right? Okay. Okay, starting from 0. We need to also keep track of the last digit. How do we keep track of the last digit? Might need to use S size 2 instead. Best digit is here, but also if there are ties, we want to fix it by checking the earliest index, right? So if and only if last digit equals k, right? In this case, this is the answer. So much. This is the right answer. We're not picking 8109. That's a shame. Why aren't we picking that? Maybe it's an off y1 error. Do we have to add +1? Oh, because it's k is less than, right? Of course. Yeah, of course. Yeah. Quick, easy solve. Mhm. Nice. We do problem for today as well. Yeah, I guess couldn't hurt. It's 10:14 p.m. right now. So we started today. Actually, nah, I've earned myself some rest. Let's commit this first. Yeah, it was a very easy solve today. Oh, before we forget, we need to check for weeks. No weeks. What was this day 3 today? Also the proof. Cool. All right, folks. Thanks.